problem 11.61. We have this flagpole. It's hinged horizontally to a wall. There's a person hanging off the end of it who has a weight of 600 newtons. The pole is 5 meters long and weighs 200 newtons. And then we have a wire supporting the pole that for part A, we want its tension to be at most 1,000 newtons to find. We need to find what the height above the hinge has to be. And then if we were to move it 0.5 meters lower, what would be the change in the tension? So we want to use the equilibrium condition that the torques cancel. So we have (200 newtons times 2.5 meters, because the weight of the pole acts at its center of mass, plus the weight from the person, so 600 newtons, times their 5 meter distance from our pivot. Now the tension in the wire is wanting to rotate it in the opposite direction of those two, so there's a negative sign. We'll call this the y component of the tension. The horizontal component, its cross product with the displacement from the pivot along the line which it acts, is 0 because it's anti-parallel to it. And this is also multiplied by 5 meters. This must be 0. So this gives us that the y part of the tension is 700 newtons. Now, we know that the magnitude of the tension is 1,000 newtons. So Tx squared plus Ty squared equals T squared. So that Tx is going to be the square root of 1,000 newtons squared minus 700 newtons squared so this will give us 714 newtons. Now, we call this angle theta. We know the opposite and adjacent lengths and also tensions, because the vertical and horizontal tension. So the tangent of that angle theta is equal to the height we're interested in divided by the 5 meters of the adjacent side, and also to the ratio of the y to the x components of the tension. So just multiply this ratio by 5 meters. And we find that the height is 4.9 meters. Now here, in part B, we move it 50 centimeters down. The y component of the tension, this had nothing to do with what this height h is. So that's going to be the same. here, tangent of theta is going to be 4.4 meters divided by 5 meters. The angle is 41.35 degrees. And so we have that the total tension is the y component divided by the sine of theta, because the y component is the total tension times the sine of theta. And this will be 1,060 newtons. So the change in the tension is 60 newtons.